Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to present about mini project on study hours and the students' academic performance. We are from CS2483B1. My group members consist of 4 people, which is Ifa Patricia, Khairunisa Alia, Fatin Nur Alia and Nadira Yasmin. Our main topic is the relationship between number of study hours, daily and academic performance, which is CGPA. First, I'm going to start with introduction. This mini project is made to find the best fit curve for the number of study hours per day. The following data from Mendeley data shows that the relationship between the number of study hours daily and the academic performance, which is CGPA. Hence, in this assignment, we will use these three mathematical model, which is linear model, quadratic model and cubic model. So for X is the number of study hours daily and Y is the CGPA. So this is our data. First is observation, which is 15 observation, and second is X, number of study hours daily, and Y is CGPA.
As you can see, the equation for linear model is y equal to a plus bx. From 15 data that we get, we can substitute into the equation by using number of study hours daily as our x and CGPA as our y. After that, we can set a matrix form, which is M is a matrix 15 by 2 and V is a matrix 15 by 1. After form a matrix M, we can find a matrix for M transpose by transposing matrix M. After that, we need to multiply M transpose with matrix M. As you can see, this is the output for matrix M transpose multiplied by M. After that, we need to multiply M transpose with Y. The output will be same like M transpose multiplied by matrix M and V. To find V, we need to inverse matrix M transpose multiplied by M. Then, you can see the output of matrix M transpose multiplied by M. After that, we need to multiply the total of M transpose M with total M transpose Y. After we get the total M transpose M multiplied by M transpose Y, we can use the output and substitute it into the formula to get the best fit of linear model. To get the error vector, we can substitute the value of M, Y and V into the error vector formula, which E equal to Y minus MV. After that, we can get the error vector. Then, if we want to find magnitude of error vector, we just put the norm to the value of error vector.
Next is quadratic model. The equation for quadratic is y equals to a plus bx plus cx squared, and we substitute all 15 data into the quadratic model and form the system of equation. Then, we convert the equation into matrix representation, which is mv equal to y. From the matrix representation, we have to transpose M. Then, by using the M transpose, we can find MTM and MTY in order to get the normal equation. So, this is the normal equation that we got. Next, from the normal equation, we have to find the value for A, B and C that represent the value of V. To do that, we have to find the MTM inverse. After finding the inverse of MTM, we have to multiply the MTM inverse with MTY to get the value for A, B and C, and also the least square solution. Therefore, this is the best fit quadratic curve that we got after substitute the value into quadratic equation. Lastly, to find the error vector, the error vector formula is E equals to Y minus MV. Then, from the error vector value, we can find the magnitude error and all the values are shown in this slide.
Next, I will present about the third model that we choose for our group project, which is cubic model. Before we solve any question, we need to write the general equation first. So, the general equation of the cubic model is y equal to a plus bx plus cx squared plus dx cubed. After that, we just need to substitute the value x and y of our data into the equation that we will get as follows. And as you can see on the right side of the slide, is the metric representation in the form of mv equal to y. Firstly, we need to find the m transpose of our data and we will get as followed. So basically, transpose of a matrix is formed by interchanging its rows and columns based on the original matrix. Secondly, we will need to find the value of m transpose n by using the m transpose that we calculated earlier multiplied with the matrix m. And thirdly, we just need to find the value of m transpose y. And it is the same as the previous matrix that we calculated, but we just change the matrix m with matrix y. Then we will get the value as followed. So this is the normal equation of our matrix in the form of m transpose mv equal to m transpose y. To find the value of a, b, c, d, we need to move the matrix m transpose m to the right side by finding its inverse matrix. Then we will get as followed. Then the formula to find the least square solution is v equal to m transpose m inverse multiplied with m transpose y. Then we will get as followed. Lastly, we just need to substitute the value of a, b, c, d that we get earlier into the general equation. Then we will get the best fit cubic curve as followed. Lastly, we just need to find the error vector by using the formula E equal to y minus mv. After we get the error vector, we just need to find the magnitude error, and we will get the magnitude error is 0.7192 to the nearest 4 decimal places.
So this is the graph of linear model, best fit curve graph and error vector against S value graph. As we can see, there is no detectable pattern in the residual plot, which suggests the linear model may be appropriate for the data. Next is the graph for quadratic model, the best fit curve graph and graph for error vector against S value. As we can see, there is also no detectable pattern in the residual plot, which also suggests the quadratic model may be appropriate for the data. And lastly, graph for cubic model, the best fit curve graph and graph for error vector against S value. There is also a not detectable pattern in the residual plot, which suggests the cubic model may be appropriate for the data. Lastly, analysis and conclusion. The best fit curve in this case, which will give the best approximation, is the cubic model best fit curve because it has the minimum error in terms of its magnitude. As we can see, the least error is cubic model with error of 0.719230769230887.